Okay, in last video we modeled mixed compression supersonic intake system in the ANSYS fluid flow fluent. So if you open this geometry, we will try to see the modeled mixed supersonic intake system of a ramjet engine. So this is the surface or geometry we created in the last video. Okay, you make sure that whatever surface or body or geometry we created, that should be defined as a fluid. Okay, so you click at the surface body and make sure that it was defined as a fluid only. Then only it is possible we can do some analysis. Okay, after closing this geometry window, now we will try to mesh our geometry. So we'll double click on mesh. Now this is our mesh window. So you can see the geometry here, the surface body. Make sure that it was given a green color tick mark. Otherwise, you will be having some issue with your geometry. And I will go to mesh. So when you click on mesh, you can see the element size. We will try to prefer the element size is 0.01, which is 1 into 10 power minus 2 meters. Then I will right click on mesh, then click on generate mesh. For our geometry, we'll be preferring the element size is 1 into 10 power minus 2 meters. Each element, whatever elements you will be seeing it here, okay, each element, whatever quadratic element, each element which is having a size of 1 into 10 power minus 2 meters. In that way will be generated this geometry. Now after creating mesh, so we'll try to create named sections. At the top we have a edge section, so I will go to edge, then I will select the left edge point. This is edge line, then I will right click it here. We will select create named selection. I will be giving name is called inlet, then click on OK. Then I will try to select the right edges. Okay, I will, with the help of pan, I will be moving my geometry into convenient location. Again, I will be going with the edge selection. I will select the first edge, then I will press Control button, then I will select the second edge. So these are the two edges I am going to select. Then right click here, create named selection. These two are my outlet now. Then okay. Okay. Then after that, with the help of pan, I try to adjust my diagram. Now, uh, I will go to again edge selection. Bottom is my axis line. I selected this edge. Then I will be giving named selection here, which is nothing but axis. Okay. After that, I will try to give named section for wall. Again, I will go to edge selection. I will select, you can see top edge. This is my top edge, you can clearly see. Then I press Control button. These are also my walls now. The bottom, this is the ramp bottom surface. This is another surface. This is another surface. We have a another inclined surface. When you zoom in, you can see a curvature will be there. You can clearly see curvature will be there. We try to select that curvature also. Okay, bottom surfaces are selected. Now we try to select the cowl. Okay, I will try to select the cowl outer surfaces. You will see this is cowl outer surface. We have another edge here, then we have a top. This is your another edge. Okay, so then I right click here, create named selection. I will be giving name as called wall. Okay, now I will cross check whether whatever named selections I given, whether they are properly inserted or not. So I will go to left portion. There I have a named selection. I will try checking inlet. So this is my inlet. Okay, it is correct. Outlet. So these two vertical lines are outlet. Then I will select the bottom horizontal is my axis. Okay. Wall, whether wall was selected properly or not. So top line it is okay. I will try to zoom with my scroll bar. Then I will see, okay, all the points are joined, or all the edges are joined properly in the wall selection. Okay, so it is finished now. Then I will right click on the mesh, update. Okay, this is how we finished the mesh translation to fluid was successful. How we will create, this is how we will finish our mesh part. Then I'm closing the mesh window. Now you can see previously geometry was given green color tick mark. Now mesh is also given green color tick mark. That means mesh and geometry is finished now. Then I will double click on setup. It is asking, uh, okay, it is asking double precision or do not show this panel. I will select with a double precision, then start. Okay, so this is the answers. It will take more time to open and close the respective window. We should have patience such that it will work properly. Otherwise, if you are continuously try to click somewhere else, it will definitely struck. Now this is our setup window. You can see here. Now it's still loading. Now it is completely loaded. It is giving some warning. So the use of axis boundary condition is not, you can see, not appropriate for the 2D 3D flow problem. Please consider changing the geom type to the symmetry or wall, or problem to be axis symmetric. So it is saying that whatever you selected geometry, it is 2D analysis. Better we try to change it to symmetry or wall. Otherwise, we will change it to axis symmetric, because whatever bottom line we selected, you can see whatever bottom line we selected, it was axis, but we mentioned here it is a planar, so it is asking us to change it to axis symmetric. Now it is okay. Now, so we'll go with a in general. Actually, in general, we have these options. In general, we will select density based. Okay, then we select axis symmetric. Okay, then we'll go to models window. In model, we have a energy tab where we try to give a tick mark for energy. That means we are owning our energy equations. Then in viscous, here we try to select inviscid flow. So whatever equations are there, x velocity, y velocity, energy equation, those equation is most suitable for the inviscid flow for this simulation. So I will click on OK. Now after viscosity, we will go with a material. So we have here in material we have a fluid. In fluid we have a air. When you double click on air, so you can see the air properties are there. So at default it is showing density is constant, but I need ideal gas behavior for my problem. So I change it to density to ideal gas. Then I click on change and create. So then we're closing this window. Then solids, it is default, it is aluminum. That in whatever wall we given, that was taken as aluminum. So we'll be not changing anything at here. Then we'll directly go to boundary condition. So when you double click on boundary condition, see, when you double click on boundary condition, will be whatever named sections you given there, it is showing it here axis. Default it is taking as a axis. If you want, you can change, but we mentioned that it is axis symmetric problem, so it is better try to keep it as a axis. Then we have a inlet. So inlet we will try to choose as a pressure for field. Okay, we'll try to choose inlet type is a pressure for field. Now this analysis is for the inlet Mach number 2. Then we will be mentioning the corresponding gas pressure, which is 26400 Pascal. So that means whatever Mach number we mentioned at the gas pressure, that is entering into the our geometry. So this is the inlet, which is showing here blue color So this is red color or outlet. So we'll be mentioning the inlet condition at here. Mach number 2 and gas pressure is 26400 pascals. Then we'll using the temperature is a constant, that is 300 Kelvin. Click on apply and close. Now then we will try to change outlet. Outlet should be pressure outlet only, will be not changing. If you want you can change, but the results are not acceptable here for this design. Then I will try to choose pressure outlet. I will try to click on edit. Here we can see we will be giving gas pressure as a 150000 pascals. Okay, then temperature should be 300 Kelvin. So this supersonic intake system, what it is doing, it is increasing the pressure from the inlet. Actually, the pressure should be increased at the exit of this portion. Okay, for that reason, I will be giving 150000 pascals. Then click on apply and close. Okay, after that, after boundary condition, we will try to go directly to monitors. In the monitors, we have a residuals. In residual we will try to give 0.00001 residual value for my continuity, x velocity, y velocity and energy equation. So this much of accuracy I required for my problem. So I'll click on OK. Then after that I have a initialization. Okay, before that you can verify methods. So here in methods you can see the formulation implicit Rio FDS flux type is there. These are the default it was taken because at the starting in general we choose density based axis symmetric and study. So according to that here methods they arranged according to our general condition. Then I will go to initialization. Here I have two types of initialization, hybrid initialization and standard initialization. I will go with a hybrid initialization. I will click on initialize. Okay, you can see total 10 iterations are there for hybrid initialization. Now I will have run calculation. I will go to run calculation. So it is asking number of iterations. I will be giving some 500 iteration. I will be choosing data file quantities. In data file quantities, default you don't have Mach number. We try to insert Mach number because we are dealing with compressible flows. So try to have a Mach number in data file quantities. Now I will be selecting Mach number here. You can see additional quantities. I will be selecting Mach number. Okay. Then I will click on calculate. You can see iteration will start. Okay, you can clearly see iteration was started. So we have a red color which is y velocity. We have green color continuity equation, blue color energy equation. They try to converging. You can see they are converging. I given 500 iterations, but they are converging very early. I think around they are plus 200 early they are converging. Now you see the calculation was completed. You can see it was converged 200. Around 200 our solution was converged. Now I try to visualize the contours. Left side I have a graphics where I have a contours. When I double click on that one, I want to see pressure. In that too I will have a different option. I can see a total pressure. So I will see static pressure. I will go to static. Then I will select all the named sections or complete geometry. I will be selecting it here, or you can simply deselect by into mark here. We can select all with a tick mark. Then you click on compute. You can see the maximum pressure, you can see 186,951.9, and the minimum pressure minus 47,828.13 pascals. But it is not visualizing it here. I want to see that one. Then I click on save and display. We can see this is how we can obtain our pressure values. Okay, I want to see clear view. So I'll be having a task page. I try to minimize this task page. I can see clearly. Okay, it is not convenient for me static structural to set it here. I will try to make this into in this direction. Okay, I can have at the bottom, or I can shift at the right side. Okay, now you can see. So actually the blue color is showing a minimum pressure at here, the red color which is having a higher pressure at here. What we required is, we required higher pressure should be obtained at the exit of this mixed supersonic intake system. Then so we need to change the inlet pressure and outlet pressure such that we will try to obtain our highest pressure at the exit of the uh, mixed compression supersonic intake system. Then I want to see velocity. I will select velocity. Here I have a velocity magnitude. I have a Mach number also. First I will try to see velocity. Compute. You can see highest velocity is 778.956 meter per second. Lowest velocity is 561.1245. When I click on save and display, so it is showing me a velocity contours. You can see similarly a highest velocity again obtained at here. Here actually we need lowest velocity and we need highest pressure. Okay, so we need to change our inlet and outlet pressure condition such that we try to obtain the highest pressure at the exit of the mixed compression supersonic intake and lowest velocity at here. And we'll try to see Mach number. In the velocity itself we have a Mach number. Then I click on compute. You can see highest Mach number 2.5199, minimum is 1.43. When I click on save and display, okay, we'll be having the highest Mach number 2.52. Again it is at the exit of the mixed supersonic intake system, but we don't obtain highest Mach number it here. We try to obtain before this one. Okay, this is how we will see the contours of a mixed supersonic intake system of a ramjet engine. Then in similar way we can have a plots here at the left side. So we'll select xy plot. Okay, here we'll have a plot. uh, we can select any one of them, or we can simply create a line here. We have a point and we have a line here. So we'll try to create a line. We'll see if I try to create a line here. Okay, I can have a first point. This is my second point. Still it is not changing. Okay, what you try to do, you try to give a dimension, x coordinate, y coordinate. Suppose I will try to draw a line from here to here. Suppose I try to draw a line from starting point at here, and this is my end point. I need coordinates. You can see this is one first coordinate point. This is my first quadrant point. This is my second quadrant point. Okay, I at here my quadrant point values are x naught and y naught value. Here my second quadrant points are x1 and y1. I will identify x1 and y1, x0, y0 along the center of my mixed supersonic intake system. I try to identify the center line for mixed supersonic intake system, and I will identify x0, y0, x1, y1. Then I will enter at here. Suppose I will be entering the x naught value 0 point, sorry, uh, minus 0.05, and y naught value, suppose I will enter 0.012, and the same y value I will be copying into, sorry, same y naught value I will be copying it here. I will be mentioning here 0.514. Suppose this is the x coordinate at x naught y naught coordinate, and x1 y1 coordinate at here. Then I will create a line here. So line 6 was created. Then along the line 5, so line 5, not line 6, along the line 5 I can plot. Y axis I have a pressure, x axis I will be having a direction. Then I click on save and plot. You can see this is the graph. Okay, this is the graph of a static pressure along the y-axis, the position along the x-axis, along the line 7. Similarly, I can plot velocity. Then I click on save and plot. I will be plotting the x velocity and pressure values along the line 5. Line 5 is already shown, the line which is passing through the center of mixed supersonic intake system. Okay, this is my velocity which is decreasing. Okay, then I can have Mach number also. Okay, along the y-axis I have a Mach number, along the x-axis I have a position. I need this type of graph, because the Mach number at the inlet to the exit, it should decrease continuously, and velocity also from the inlet to the outlet, it should decrease. So these type of graphs I need. And similarly I need pressure should be increases from the inlet to the exit. Okay, these type of graphs are required for our problem. Okay, this is how we will finish our setup window. Okay, then I will try to close this setup window, save for current and future calculation.